Hey guys, so I've been thinking about synthesizing adipic acid for a while now. I saw a video from nilered almost 6 years ago where he uses a new green route to make adipic acid using cyclohexanol and hydrogen peroxide as reagents and tungsten metal as catalyst. The industrial method of producing adipic acid uses nitric acid as oxidant, and it is not very environmentally friendly because of nitrous oxide gas as side product. In the alternative version, the side product is just oxygen gas, and the reaction medium containing the catalyst can be used repetitively to produce adipic acid. I googled the paper that nilered used and I didn't find anything. If you have the link to the article, please leave a link to it in the comments. He also didn't get good yield and purity, mostly because he used low-grade reagents with unknown impurities. During the reaction, he experienced runaway reaction that he had to control by using an ice bath. That was not mentioned in the paper also. So I decided to try and make adipic acid using higher purity of reagents to see if the process is worth considering as an industrial alternative. I'm not going to get into the mechanism of the reaction, but in summary, it's the oxidation of cyclohexanol to cyclohexanone and then through a series of oxidations to adipic acid. If you want to know more about the reaction, I have left the link to nilered's video in the description. There is a thorough explanation of the paper and the mechanism in the video. So let's begin. I started by tearing a small beaker so that I can add 1.5 grams of tungsten metal powder. I bought tungsten powder for another reaction and I was lucky that I had some left. I also measured around 270 grams of hydrogen peroxide. The hydrogen peroxide that I used was sold as 30% industrial grade hydrogen peroxide, which has been tested by an analytical lab to be 29.8% hydrogen peroxide. So now I'm gonna add the tungsten powder to the hydrogen peroxide and start heating. By heating the mixture, tungsten will form a complex called tungstenic acid, which is actually the catalyst of the reaction. So just a little bit of back and forth to get all of the tungsten powder out of the beaker and continue with the heating. So after a while, most of the tungsten has dissolved in the hydrogen peroxide, but it doesn't matter that all of it dissolved. We can add the cyclohexanol and continue with the heating, and the remaining of the tungsten will react and dissolve in the hydrogen peroxide then. Cyclohexanol has a density of 0.96 grams per cubic centimeters, melting point of 25 degrees Celsius, and boiling point of 162 degrees Celsius. I got the sample from a supplier of industrial grade cyclohexanol and I vacuum distilled it and collected everything below 90 degrees Celsius. Then I put the sample in the fridge and drained everything not frozen below 15 degrees Celsius. Then I checked the density and it matched the 0.96 grams per milliliter, so I consider it quite pure. I'm going to measure 50 grams of cyclohexanol, which equals to half a mole. Cyclohexanol has 100 grams per mole as molecular weight, so 50 grams is half a mole of cyclohexanol. So I'm going to add everything to a bigger flask to start heating. So I'm gonna add a thermometer for now while I set up a reflux condenser. You want to use a condenser with water running through the tube, not the shell, because vapors and liquid in a small tube might clog and splash. So I have set up the mixture for heating and I'm gonna wait for it to boil. So the mixture started boiling at around 90 degrees Celsius and rised up to 95 and stayed constant for the rest of the reaction. I let it reflux for 24 hours and came back the next day for the workup. As you can see, the mixture has cleared up and the cyclohexanol is no longer present to form a layer, and the adipic acid is dissolved in the boiling water. I let it cool to room temperature and then put it in the freezer for an hour to get all the adipic acid that has dissolved in the water to precipitate out. So I'm going to filter the adipic acid using a paper towel because I had a stupid idea and wanted to test it. Filtration was good. You can see the water passing through is clear, but paper towel is not a good medium for filtration as it tends to tear up, and maybe it might have some plastic covering to dissolve in your mixture. I don't recommend it. The water passing through had an awful smell, almost like some kind of biological waste, and it was discarded. So I washed the adipic acid with some distilled water. So every time I washed the adipic acid with some water, the smell decreased, and with the last washing the water did not smell. So I'm gonna put the paper towel containing the adipic acid on some plastic bag to dry. So I just moved around the adipic acid a little bit and removed the magnetic stir bar. I'm gonna leave it for 24 hours to dry. So one of the reasons that paper towel is not a good filter paper is that it tends to stick to the product. As you can see by scraping off the adipic acid, I leave behind some product. So I weighed the paper towel before adding the adipic acid mixture to it, and it was increased in weight by 1 gram. After drying, the mixture was around 35 grams. I didn't check the purity because the yield was not good enough. The yield was around 48%, and it's not financially feasible to produce adipic acid from this route. So maybe there's a reason I couldn't find the paper and it might be retracted. If you have suggestions of how to improve yield and purity, please leave a comment. Stay tuned for more videos. Thank you for watching. Please like and subscribe.